There's no arguing that glass cockpits like the Garmin G1000 NXI can make it easier to maintain situational awareness during a flight, as long as we understand all the indications we're given and how they're generated. Understanding the G1000 is what this video and many more are all about, and they're all coming together into a full G1000 course which will be ready in February or March of 2022, along with plenty of other training courses at flight-insight.com, so dash on over there. We all remember cross-country flight planning using the E6B flight computer for pilotage and dead reckoning calculations to determine things like wind speed and direction at altitude. These are taken care of for us by our avionics now. To help us fully see this, let's first bring up some system information by hitting the engine soft key on the MFD and then the system soft key. Here in this box just to the left of the HSI is a wind indicator. Now there's simply no reliable means of getting an accurate winds aloft report from any point in our flight like we can from a METAR on the ground, so this wind report is generated completely from data on board our aircraft. Right now, the wind indication is saying that we have a 20-knot direct headwind right in our face. This doesn't produce any crosswind, as we can see from the fact that the flight path marker, this little green circle or meatball, which predicts where the airplane is going, is laid right over where the aircraft is heading. Our heading and course are the same with no crosswind. As we make a right turn though, that arrow on the wind indication starts to rotate, showing more and more of a crosswind. As we roll out of the turn, now notice the meatball is off to the right, indicating the wind is pushing us in that direction. Also notice the small pink diamond on the HSI, which is our track as determined from GPS, also confirming that we're moving to the right of our aircraft heading thanks to the wind. We have three options for how we can have this wind information displayed. If we hit the PFD option soft key and then the wind soft key, we see that we're currently looking at option 2. Option 1 gives our headwind component of 5 knots and our crosswind component of 19. Another piece of information we won't need the E6B for. Option 3 will actually tell us the wind direction in degrees and the velocity. How is the system able to give such accurate winds aloft reports? It turns out it's not doing it much differently than if we pulled out a navlog and did the math ourselves. We can understand this by looking first at indicated or reported values right off of our instrument panel. We could think of these as things we would know even using a traditional steam gauge setup. Then there are computed values, which we would have to sit down and do the math for, but the avionics will take care of for us. The values we already have at our fingertips are our altitude of 5,500 feet, our indicated airspeed of 163 knots, the outside air temperature of -15 Celsius, the altimeter setting of 3047, and a heading of 059 degrees. Again, these are all things we would know flying with a round dial cockpit too. The outside air temp isn't a required piece of equipment, but most older aircraft will still have them. The altimeter setting isn't indicated by the instruments per se, it's reported from ATC or a nearby AWOS, and the heading would come off of a compass. In the G1000 it uses a magnetometer to produce the same result without having to worry about magnetic dip. With these figures we can derive other values that will help to compute wind speed and direction. First we need a pressure altitude. We have a rule of thumb formula for this by taking the altitude and altimeter setting. The G1000 does this a bit differently. It doesn't need the reported altimeter setting, but the result is somewhat the same. Our pressure altitude is around 5,000 feet. Next we want to know our density altitude. This is calculated from the pressure altitude and the outside air temperature and is around 2,500 feet. This is actually displayed on the MFD when we brought up the system information earlier. As we said, it's calculated a bit differently than we're used to, but with a similar result. Next we want to know our true airspeed. Remember that the airspeed on the ASI that's showing 163 knots may not be our true airspeed, because higher or lower air density in the pitot static system will affect the readout. We have to take our indicated airspeed and the density altitude to determine our true airspeed. The system will calculate this, taking into account calibrated airspeed differences as well, to get our true airspeed of 169 knots. This is displayed just below the airspeed tape. Next we'll want to know our ground speed and our track. You may remember having to time with a stopwatch the interval between two waypoints on your check ride. This is how you'd come up with your ground speed and the difference between your heading and track, the last two values we need in order to get that wind information. Here the GPS does it for us. It times how long it takes to get between two positions it observes and draws a line between them to determine track. These are both displayed at the top of the MFD in pink. So we finally got what we need to calculate wind direction and velocity. For this, we need the true airspeed and ground speed, which will tell us our head or tailwind component, and we need our heading and track, which determine crosswind component. Combining all this gets us our wind direction of 343 degrees and speed of 20 knots, all without having to touch the E6B. Knowing these values and what factors go into deriving them can give a great boost to your situational awareness in a flight and have a real-time tool to help you make needed changes to a route or plan. Let's go back to this concept of indicated versus true airspeed and see it in action on the G1000. You might remember from private training that as you climb into less dense air, the pitot tube will detect less ram pressure. So in order for you to get the same airspeed indication, you need to be going faster in order to ram more of those air molecules into the system. We could see it if we enter a constant airspeed climb here. We're starting at 5,500 feet and we'll select a climb to 10,500. We'll have the autopilot pitch up at a constant airspeed by hitting the IAS key and rolling the wheel to set a speed of about 125 as you see above the airspeed tape. Now, as we establish into the climb at that speed, notice that we're at a true airspeed of 132 knots. But watch as we maintain the indicated speed and climb into higher, less dense air. We actually true out at around 140 knots, so even though the pitot-static system is reading a constant speed of 124, 125, our actual speed through the air has increased. And by the time we level off and cruise up here, we see that we have an extra 20 knots of true airspeed on top of that indicated 160. Now, one last thing that should be pretty obvious by now, but is nice to see for ourselves, we have an almost direct crosswind with a slight tailwind component up here. Our true airspeed is around 185 knots, but our ground speed is about 5 knots faster, thanks to this small tailwind component. If we make a right turn so that now this wind is coming much more from our rear than from our left, notice the bonus we pick up in ground speed. Even though we're still at a constant true airspeed, we're now seeing ground speeds above 200 knots. And that arrow showing the wind vector is a great visualization of why that's happening. With glass cockpits, we've taken one of the hardest things about aviation, the fact that we can't see the wind we're flying in, and brought it right in front of our eyes.